Hi everyone, today I'm going to introduce a system programming class in the curriculum of the Department of Electrical Engineering and Computer Science of GIST, Gwangju Institute of Science and Technology. The class title is System Programming and the course number is EC3215. Every week has 3 hours of classes and my name is Jin-seok Gong. When it comes to computer systems, many people take input and output devices and the operating systems for granted. They double-click to launch their program. They use I/O devices that work well without much thought. They don't mind what happens within the operating system most of the time. Actually, very few people truly understand how a computer nearly works at a low level inside the computer. There are many classes that expand knowledge about the inside of computers, such as operating system classes and computer architecture classes. This course will expand that knowledge by writing programs that run on the Unix operating system. More specifically, this class teaches you the programming interface to the Unix system. In other words, this class teaches you the system calls and many of the functions provided in the standard C library. Also, by any chance, if you work in a computer-related field in the future, you will have more opportunity to directly manipulate the Unix system calls yourself. Let's take a look at the inside of the computer system briefly. The figure of the slide shows a structured view of the computer system. At the top layer of the structure is the user application layer. User programs or other system programs are included in this layer. The operating system kernel is placed in a layer below, the middle layer. The kernel provides services to the operator. In other words, user application can use the services. To request services from the kernel, a higher layer program must use a program interface called system calls. The kernel controls underlying hardware to serve the received request. The underlying hardware resources include CPU, memory, disk, etc. The figure shows 8 services provided by the kernel: program execution, I/O operation, file systems, communication, resource allocation, accounting, error detection, protection, and security. The lower figure of the slide shows a timeline view of the computer system. The user program runs first in user mode. We call the running program a process. When the process reaches a system call, a transaction from user mode to kernel mode occurs. The kernel now runs in kernel mode. After completing the service, the kernel returns control to the user process while changing the mode to user mode. The example on this slide shows a read function call in your program to get a read service from the kernel. The read service loads data from a file on a hardware disk. Actually, the read function is defined in the C library. Therefore, that C library function issues the corresponding system call. The system call calls the transition from user mode to kernel mode and start running the kernel function called syscall handler. This syscall handler invokes another kernel function, VFS read, to perform the received service. Eventually, the disk device driver that controls the disk hardware reads the data from the file and stores it in memory. The kernel returns the data in memory to the user process. This is a brief description of GIS system programming class. We will discuss system calls and how they work in the kernel in detail in class. Thank you for watching the video.